In this video, we are going to discuss the method of performing an integration on an improper fractional function as seen in example 14. The fractional functions to be integrated in this example 14 is an improper fraction. It is improper because the order of the polynomial in the numerator is larger than the order of the polynomial in the denominator. To perform the integrations, we have to first reduce the improper fractional function into an proper one. To reduce the improper fractional function into an proper fraction, we have to apply what we call the long division. Let's see how long division can be performed on this fractional function. So first, you write down the numerator polynomial in the division symbol, and you write the denominator function outside. To get rid of this factor of 2x cubed, you have to multiply the x power 2 term by a factor of 2x. That will give you 2x power 3. 2x will multiply with minus 2x here to give you 4x. 2x multiplied with minus 3 give you minus 6x. Then you take the difference between this line and this line. The term 2x cubed will get cancelled off, so is the minus 4x squared term. So here there is a x squared term which I've forgotten. Minus x term minus 6x will give you 5x. Then this term minus 3 will be brought down to be minus 3. So that's how we perform the long division. As a result of this long division, the improper fractions is now reduced to an proper one, which is comprised of a linear factor 2x plus its remainder term 5x minus 3 sitting on top of x squared minus 2x minus 3. So we have successfully reduced the improper fractional function into an proper fractional function. The integrations of example 14 can proceed by performing integrations on this proper fractional function using the method of partial fraction. Let us first integrate the functions of 2x. This should give you x squared plus an integrations of the proper fractional function as written here. Proceed with the integrations for the proper fractional function. We cast the integrand into the sum of partial fractions. First, decompose the denominator function into the product of two linear factors, namely x minus 3 and x plus 1. We then can express this proper fractional function as a sum of an linear term a over x minus 3 and another linear factor of b over x plus 1. We continue to add the two partial fraction terms together, and we will collect the terms that is the coefficient to x and the term that is the coefficient to x power 0. So the coefficients to x comprise of this term a and the term of b. So we have a plus b. The term that is independent of x would come from a and minus 3b. Comparing the left-hand side and the right-hand side of these equations, the coefficients to the x term is 5. Therefore, a plus b must be 5. The term a minus 3b must be identified with minus 3. So I call this equation 1 and I'll call this equation 2. Taking the difference between equation 1 and equation 2 will give you 4b on the left, and on the right hand side it will be 8. Therefore, b is simply equals to 2. A is equals to 5 minus b equals to 3. So now this proper fractional integration can then be expressed as the sum of a over x minus 3 plus b of x plus 2 integrate with respect to x, where a is 3 and b is 2. The integrations of this term give you a log term, so is this term. So that completes our discussions of example 14. And the result is this term as shown on the screen plus an arbitrary constant. As a conclusion, in order to perform an integration on an improper fractional function using the method of partial fraction, we have to first reduce the improper fractional function into an proper one. The proper fractional function that you obtain after long division can then be expressed into the sums of two partial fractions, and using the standard techniques of comparing the coefficient to x and the coefficients independent of x, you'll be able to obtain the numerical values of a and b. Then the integrations can be performed on the partial fraction terms to give you the results of the integration straightforwardly.